Okay, so what we have here is an activity that was handed out to you, like I believe it was last week. Well, sure, it was last week. And I gave you time in class to try to get it done and then asked you to try to finish it for homework. And there was a lot of confusion on what exactly was going on. And this goes back to the idea that this activity is an application of a concept. And this is a big difference, I guess, from a lot of your experiences from what you're telling me in your surveys and in your one-on-one question and answer. You're not used to, or a lot of you aren't used to applying the knowledge that you gain from, let's say, a PowerPoint or a class lecture or some one-on-one tutoring. And you have to apply it in this case. And so you have to think about what these mean. These two structures here, this hexagon and this hexagon, are each a monomer. And we've discussed this. Hopefully you've watched the previous video and you know what a monomer is. You know what the monomer of glucose is. Now here we're talking about dehydration synthesis. Again, I went over it in detail in the last video, and this activity was meant for you to apply that idea of dehydration synthesis. So if you didn't understand dehydration synthesis, it was going to be difficult for you to apply it. And that's why I give you these activities. And by the way, this is what the state and all the colleges expect you to be able to do. This is the main skill that you have to, well, one of the many main skills that you have to learn to be able to do so that you can be successful at a competitive college or even on your end of course exam in April. So here you have these two ideas of a monomer, that they're joined together by this concept of dehydration synthesis. You can see here the words are being used in the paragraph, dehydration synthesis, and the word monomer is used here, right? And we're going to try to simulate the reaction. It's a chemical reaction, right? We've talked about that. It's driven by an enzyme, which is not mentioned here, at least not in the paragraph. And it tells you again that, you know, when we're talking about smaller repeating units, we're talking about monomers. And there it is again, over and over again. It's described to you. It's repeated. I've said it in class. It's in the text. Blah, blah, blah. So hopefully you get the idea that these ideas of monomers are repeated units. In this case, in the case of this hexagonal shape, hopefully you recognize it as one of the many ways we draw sugar, like glucose. It could be glucose, it could be galactose, right? Now those are both hexagons. They both form hexagons when they're in a ring structure. But let's go ahead and assume they're glucose. You take these two sugars and you're going to bond them together, and you're going to make something on this end. Well, hopefully by now, if you've studied and you understand the concept, then you know you're taking this and this and you're bonding it together and you're making a disaccharide. You're only making a disaccharide because you only start with two. But if you had 1,000 of them over here, you could end up with a polysaccharide that's 1,000 units long. Okay, so that idea should be solid in your head by now, I hope. If not, we'll have to work that out, hopefully before tomorrow, or before Tuesday, because the quiz is on Tuesday. And if not before Tuesday, then hopefully afterwards in after school sessions before the exam. With the two remaining monomers, it says, cut out the detail. So you take these two, they want you to take these two in step 2. They want you first in step 1, they want you to cut out along solid lines, and you'll see on the next page what those cutouts look like. And then they want you to take, so you're going to cut out 4 of these carbon monomers. There's 4 monomers on the next page. You're going to take 2 of them and you're going to put them on this side of the arrow. You can draw an arrow on a piece of paper. On this side you're going to have the monomers, and on this side you're going to have them after. These are the reactants, and these will be the products. So what's the product of this idea of dehydration synthesis? It's some kind of disaccharide or polysaccharide or something like that. So when we're talking about this particular reaction, we're focusing on a reaction. I'm sure Mr. Desipeda or some other or your chemistry teacher next year will talk about all kinds of chemical reactions. But in this particular type of chemical reaction, we're calling it dehydration synthesis, and we talked about why. We're producing water, hence dehydration, and we're putting things together, we're building things, so hence the word synthesis. So with the remaining two monomers, that's the two that will be left, you're going to cut along the dotted lines, fit the two monomers together, and glue them down on the right side of the arrow. Also fit together the hydrogen and hydroxide pieces and glue them together onto the construction paper. Now I asked you to do that. We'll talk about that. We'll go ahead and do that in a second here on this in this small vignette. But here you have these questions. Let's look at each of the questions before we do it. So let's try to remember what's important as we're doing the project. So what atoms were cut off in the original monomer? So let's think about that. If you watched the previous video, you should know that you're going to remove a hydrogen off one and a hydroxide off the other so that you can form water, H2O. So we know we're going to form H2O. We know that. Let's think about what we know. This is problem solving 101. Write down what you're being asked to do and then write down what you know. You know you're going to form H2O, right? Hopefully you know that. You're going to get from one molecule, one monomer, you're going to get a hydrogen. And from the other monomer, you're going to get OH. You know that if you watched the video, if you paid attention in class, if you did the reading. So from one, you're going to get the OH. From the other, you're going to get the H. And those are going to come off here and here. And you know that you're going to connect one oxygen. It's going to connect to the other carbon. And we talked all about it. And go watch the other video if you didn't get it. I don't want to go into details here. Just want to focus on the answers to these questions. So we'll come back to try to fill these in, but let's look at the rest of the questions and make sure we understand what we're looking for. So they want to know what atoms are you cutting off, and why do they want to know that? So that they want to check, and I want to check, do you understand dehydration synthesis? Do you understand that each carbon can only have 4 bonds, that each oxygen can only have 2, and each hydrogen 1? And so therefore, when you want to link this one and this one together, something has to give. Something has to be removed from each of these in order to be able to fit them together. In the macromolecule, a new bond is created between the two atoms. So as you create a macromolecule, which means a bigger, macro means big, okay? Just in case you didn't know that. Macro means big. So when you think of micro, you think small. You think macro, you're thinking big. And of course, what kinds of big molecules have we been talking about? We've been talking about dimers, right? And dimers, and specifically in this one, disaccharide, because it's a sugar, and we've been talking about polymers. And specifically in sugars, we've been talking about polysaccharides. But polymers is the other one. Mers meaning more than one repeated unit, and dimer meaning 2, but either way, they're bigger molecules than the monomer. Then finally, the next question that they're asking you, again, they ask you it created what 2 atoms? So what are the new bond is created between what 2 atoms? Again, they want to know, do you understand what's connecting these two on this end at the product level? And fourth and last question, by the way, don't be surprised if some of these questions end up on the quiz, because it's important that you understand this, because it's the same basic process for DNA, for RNA, for sugars, polysaccharides, disaccharides, and for proteins. So in all of them, it's the same process. So you understand this process in sugars, it should become very quickly in the other 3. If you don't understand in sugars, it's going to be that much harder when we're talking about in the other 4, in the other 3, the other 2 macromolecules. Macromolecules, what are they? Large molecules. What large molecules might we be talking about? Polysaccharides, proteins, nucleic DNA and RNA. Those are large molecules. So then here the last question, the backwards reaction in dehydration synthesis is called hydrolysis. Hydro refers to water, lysis them to break, explain what happens in the hydrolysis reaction. You should be able to do that. I'm not going to give you the answers in this video, but I'm going to point you in the right direction. You need to watch the other video, think about what's happening, and be able to answer these. I thought about just giving you the answers, but I don't think you'll learn much if I just give you the answers and you write them down. If you watch the video and think about these questions, you should be able to answer the questions. If you can't, then maybe we do need to spend some time after school and catch up and try to get some tutoring time in. Let's look at the next slide and try to put these together. All right, so as we discussed in the last, just a moment ago in the questions, you have these 4 monomers, and the 4 monomers represent sugars. Now you please notice that even though you don't see the atoms labeled, there are atoms here, and they're not trying to tell you that this is carbon, they're just saying there's some of these atoms here, let's not worry about it. Here's some R group. This R group, remember, is a variable. It's sticking up out here. We're not going to worry about that either. What we're worried about is how do we get 2 of these monomers linked together, and that's going to have something to do with this side and something to do with this side. So you see the 2 sides of the monomer that are going to be involved in making this polymer or dimer. Remember what the difference between dimer and polymer is that dimer is only 2 and polymer is many. Then you got that one that's in the middle that's called oligomer. So just remember that as we move forward. Okay, so one of the big questions that they have in the question sheet is which one of these 2 has to leave. When we connect these 2 here, which one of the atoms are going to have to leave, and which one of the atoms connects these 2? Now I've seen people connect all 4 of them together in a circle. I didn't understand that, and I said because what happened was with that person, I think, is that they didn't think of that. They didn't read the directions, and they didn't see that number 1 tells them to cut them out, and number 2 tells them that these 2 are in the beginning, and we call them reactants. And so you draw out, you would go ahead and put them as 1, just like we had in the other video, and 2, that these are the reactants, right? And they haven't reacted yet. They haven't been put together yet. So they don't change. So you just take these 2 here and you put them together on this side of the arrow. What arrow? The arrow you're about to draw, that arrow that represents the division, the separation of before and after, right? I'm going to draw a big arrow this way and a little one this way. You'll understand a little bit because it's a reversible reaction depending on which enzyme you have. Right now we're talking about the forward reaction, and then we can reverse it. Right? That's going to be an important concept, that you can reverse reactions, that you don't have to be stuck with a particular direction in a chemical reaction. So you have these 2 monomers, I grant you this one's badly drawn, are going to link them together. It's better drawn here, but not perfectly, but the whole point is that you're worried about the two active sites, the 2 places that are going to be involved in the chemical reaction. So as you try to link these together, you have to remember hydrogen can only make 1 bond, and carbon can make 4, and oxygen only 2. So how are we going to bond these together? Well, I've seen people take this off and take this off. So in that case, you'd have 2 hydroxides. You can't make H2O from that. Because remember, one of the products that we know we're going to make is H2O. That's 2 hydrogens and an oxygen. So you need 2 hydrogens and an oxygen. If you remove 2 hydroxides, in other words, you take this hydroxide and this, that's what you're going to do with these 2, by the way. These 2 you cut out and you paste up here, right? So if this is 1 and this is 2, this would be 1 and this is 2, right? And then if you're taking and you're thinking about the opposite side, right, where you have at the end, you're going to have these 2 monomers. They used to be monomers linked by some unknown atom. You know what atom that is by now, but we're going to, if you've watched the videos, but we'll go ahead and say unknown. and we have these two that are linked, and that's 3 and 4, and that's represented here by these 3 and 4. So at this point, their whole objective is that you want to take these two monomers and you want to link them together with some via one of these atoms. I don't know which one yet. You'll have to think about it. You'll have to figure it out. You'll have to watch the video and answer it. Is as you cut these out, what atom is going to connect these two? So let's think about it. And I mean, geez, I've sent you a couple videos already that talked about doing this and discussed exactly which atom it is that connects these two. The last video I sent you clearly shows what atom is connecting the two. It clearly shows which one of these leaves. I don't want to tell you on this video. I want you to go ahead and make that connection. I want you to figure it out yourself. I want you to take ownership of this knowledge and figure this stuff out. So in this activity, you were supposed to take this monomer and connect them using some kind of chemical reaction that rearranges. Now, they gave you a hint. It's more than a hint. They put a dotted line. So you have to cut, not these two. 1 and 2 are set. They're monomers. That's the way the molecules are. It's on this side, on the product side. Remember, this is the product side. And when you're talking about the product side, you're talking about the side that's after the chemical reaction is done, right? Where this one is before the chemical reaction, this one's after. When you're done with this particular chemical reaction, you're going to have two things that are linked together using some atom, some bond between this thing and this thing that wasn't there before. And you have to have a water being formed, right? So water wasn't there before, was it? There was no water there before. Now there's water here. So before no water, after there's water produced. The point of this hydrolysis reaction is not to form water, but to form this, in this case, dimer, and specifically disaccharide, and the byproduct is water. Water is a result as well, but it's not the main reason why they're being put together. They're being put together in order to make these polysaccharides that we call, specifically in animals, we're talking about glycogen, right? In plants, they're called starch. Both glycogen and starch are temporary storage of sugars to get them out of the system, because it's no good for having too much sugar in our blood. So what our body does is it makes these polymers and puts them away. And first is glycogen, and then when we're done, when we filled up every spot of glycogen, then we start making fat. Okay? Now when we talk about plants, they store it in starch. Now when they want to create this, when they want to create structures, they use something called cellulose. And bacteria will also use cellulose. Some bacteria, some fungi. But there's, no, not bacteria, I'm sorry, but some fungi will use cellulose. Most other bacteria and such, they will use other forms of the same idea of using these monomers and putting together into these polymers. And the difference is how they're put together, which atoms are bonded to which atom, etc. So in any case, the point is that in this activity, your job is to take these two and put them on one side of the arrow, and these two and put them on the other side of the arrow. They produce a product. You link them together. They're using some kind of atom here that's linking them together. Hopefully you're paid attention. Hopefully you've watched the video. Hopefully you've read the book. Hopefully you've watched any number of the 3 or 4 videos that I've sent you on this process. One professionally done, which is an excellent job. And you get the idea of what links these two together. I really hope that that's the case. Then the next question, though, you see the dotted lines. What are you going to do? I've seen people, as I said, cut this and this off and try to put these two together. That's not going to make H2O. That's going to make H2O2. That's no good. H2O2 is not H2O. It's something else, right? I've seen people take the 2 hydrogens off and try to link them together. That doesn't make sense, because then you end up with H2 and no O. You need H2O. So look at this and tell me, between these two atoms, you cut, because you're not cutting anything off 1 and 2, you're only cutting things off 3 and 4. What can you cut off in order to make an H2O? Think. You have these options. Now, I've also seen someone cut off all 4 of them. As I said, in one person actually cut off all 4 of the monomers and put them together in a circle. That's no good. But 3 and 4, I've seen people cut this one off, this one off, this one off, and this one off, and then put 2 H2Os, and then I don't even understand. They just kind of link 3 and 4 together without really thinking about what's going to bond to what. If you follow the dotted line, this carbon, so let's say for a moment, now I'll go ahead and walk you through it, but I'm not answering any of the questions. I'm just going to walk you through it. If I cut the hydrogen off this, right, the dotted line, I could cut the hydrogen off this. It doesn't matter because they're the same, right? 3 and 4 are the same, just like 1 and 2 are the same. Look at them. There's no difference. So I can cut this off here, the hydrogen off here. What must I cut off on 3 in order to put them together? Why am I cutting anything off to begin with? I hope that you answered that we need to clear some bonds. I hope you watched the video and know that you have to clear some bonds, because this oxygen can only make 2 bonds, one here and one here. That's 2. That's taken up. Every atom in this molecule has all its bonds taken up. Every atom in this molecule has all its bonds taken up. They're all connected to one another, stable and ready to go. This one as well. So in order to link them, we have to get rid of some bonds. So if we cut this hydrogen off, we've cleared a bond. Where is that bond? What is this connected to? It's connected to this oxygen. It's not connected to carbon. This oxygen is connected to the carbon. So think, right? You have to think about what that means. You have to think about the fact that this hydrogen is connected to this oxygen, and then this oxygen, then this oxygen is connected to this carbon. So when you take, like I just said, if we decided to take this hydrogen off, that's a hydrogen that's going to come out. What else do I have to take off to get this H2O? Am I going to take this off on the same molecule? That doesn't make sense, because I'll get H2O if I cut this. You're right. I'll get H2O, an OH and an H. That's H plus an O. That's H2O. I got that. I can do that. But that doesn't leave me with a bond open on this molecule. I need one bond open on this molecule and one bond open on this molecule. If I cut this off, that opens up a bond on molecule 4. But on molecule 3, what do I have to cut off? What has to come off in order to make this H2O? Well, I'll go ahead and say it. Gosh, I hate doing this. But I'll go ahead and say it. What needs to come off is this OH, right? Because if I took the H off, then I'd end up with H2, but no O. So I need to cut something off that gives me H2O in the end. And if I cut this off, now the hydrogens come off. Now I have hydroxide, OH, and it's ready to go. So now I have an H and an OH, an H and an OH. That's H2O, and that's my water. I'm good. Now the next question is, what was this this oxygen was connected to this carbon and then again to this hydrogen. The OH came off altogether, so that leaves you with a carbon connected to the rest of the molecule, right? This carbon still has connected to the R group. It's still connected to this carbon. It's still connected to this carbon. So it's still part of this molecule, the carbon is. The OH is gone, but this carbon is missing a bond now. And then when we look on the other molecule, this molecule has an oxygen that's still connected to this carbon, right? This oxygen is still there. Hydrogen left, but the oxygen is still there, and it's connected to this carbon, which is connected to every other atom in this molecule. So, but this oxygen has an open bond ready to go. So now this oxygen is going to connect to what in 3? That's the question. think about it, rewind it, do whatever you got to do to figure it out. Go back and watch the other video. But somehow we just opened a bond on 4, and we opened a bond on 3. It has to be this combination. You can't combine H and H to form H2O. You have only H2. You can't combine OH and OH to form H2O. You'd only form H2O2, which is hydrogen peroxide. We worked with it last week in our lab. So what can you connect between these two to make it happen? Think. Hopefully it's obvious, and if it's not, watch the other video and then come back and watch this. And I hope you get it right on the quiz, but if you don't, you're still confused, let's go ahead and look at it together after school, and hopefully you'll be able to get it right on the test. All right, I didn't want to give you too much. I think I might have given you too much, but we'll go ahead and look at the questions again, and then we'll hopefully we'll see a complete product Tuesday. All right, so here we have dehydration. So back to the original sheet, and as I said, these were the directions. It told you to cut along the solid lines. It told you on the back of this paper. It said in the back of this paper. I kind of wanted you to go ahead and do it on a different sheet of paper so we can cut them out. The process here in this particular activity was just to make a disaccharide. I thought we could take it to the next level and make a polysaccharide on the board. Like I said, fifth block was able to do that. We got this big long polysaccharide, just a big long chain. We got hopefully the idea is set in your head of what the whole purpose of this is. And then secondly, we can glue 2 monomers down, all right, on one side of the arrow. So you glue them down like this. It says it here. That's why gluing all 4 of them together didn't make any sense. You don't change these because these are the reactants. I've said that in the video, so I don't mind writing it again. This side's reactants. So this is before the reaction. It's on this side that we have to worry about what goes. All right, and here we're going to form products. And on this side, the products, we know there's going to be 2 of them. One is going to be something that that we come up with two monosaccharides put together to make a disaccharide, and the other thing we're going to make is water, right? So this is something. These are the 2 products that are going to be made by this reaction. So with the remaining 2 monomers, cut along the dotted lines. Well, which dotted lines do you cut off? Well, that's the question you got to figure out. Rewind the video, look at that question, watch the previous video, think about it, listen to the lectures, read the book, whatever it is you got to do. Watch the professional video I sent to you. Whatever it is you got to do to try to figure out which 2 dotted lines do I cut off to get the right answer. Then fit the 2 monomers together and glue them down on the right side. That's what goes here. A lot of you have done this correctly, but there's still a few of you out there. I know it. I've seen your work. I know that you haven't yet. You're still not getting 100%, and I want to make sure you get an A on this quiz on Tuesday. So spend this time. Make sure you understand it. If you got it done and you copied off someone because you just wanted to get the activity done, please go through and try to do the reaction. Try to do the activity on your own. Make sure you understand what we're talking about here. So when you see a question on Tuesday about this process, you got it straight in your head. All right, so fit them together, the hydrogen hydroxide pieces, and glue them. See, they already gave it to you. The answer is given to you in the directions. Fit the hydrogen and hydroxide pieces together to make H2O. They gave you the answer right there. I'm not going to explain it. You should be able to figure that out. Rewind the video, see what I'm asking you to do, and look at and then think about this. Also, fit the 2 monomers and glue them together, right side on the right side of the arrow. That's what goes here, and then fit the other 2 together, the hydrogen and the hydroxide, to form the H2O. What atoms are cut off in the original monomers? Think about it. The answer is already given to you in the directions. You look at what we said a minute ago. Right, and see in the previous previous minute and a half or so, 4 minutes ago, and look and see what new molecules were formed. What new molecule was formed from what? From the ones that were cut up. You should be able to know that. And I'll ask you another one. Oh, well, here's the next question. In the macromolecule, what's the one this is the macromolecule, the one that's 2 molecules put together. The big molecule, macro meaning big. The new bomb created was between what 2 atoms? So what 2 atoms connect these 2? And then finally, well, I'm going to add another question for you. Think about it. If this new molecule that was formed was from the two atoms that were cut off the original monomers, what was the other molecule? There's two new molecules that are formed. One's a macromolecule, and the other one is shown above. How's that? It's shown here already in the product side. The other one is the macromolecule. What's the other one as well? And then what happens when you reverse this reaction? Think about it. You can go back and look at the videos. You can read the book, whatever it is you need to do. What happens in the opposite direction? All right, if you did all that, you'll get an A on the lab, check. But then the question is, do you understand what's going to be on the quiz? So for the quiz, I hope you understand that you have to understand both dehydration synthesis, right? And that's this whole thing that we just went over. And I want you to remember that it's also called condensation, a condensation reaction, but that's fine, dehydration synthesis. The other thing you have to remember is hydrolysis, which I don't go through here, but I did in previous videos. It's in the book as well. And all the other things like functional groups, don't forget functional groups, etc. Because all that will be on the quiz. There's only 25 questions. Please look at the syllabus I sent you at the beginning of last week, and it lists for you a test blueprint that breaks down exactly how many questions are coming off each section. This particular set is probably, this is what the whole this is the metabolism of sugars that we talked about. That's the whole section. So there's a number of questions coming off of this dehydration, synthesis, and hydrolysis. All right, good luck. I hope this helps. If you have any questions or you're still confused about something, please write down specific questions and email me. If I can quickly answer them back in email, I will. If I need to create another video or find another professional video to find that'll help you understand, that's great. All right, good luck to you. Bye-bye.